In this video, we are going to introduce a definition of central angle and inscribed angle, and also we are also going to introduce a relationship between these two types of angles. So the first, as we discussed in the class, central angle is the angle. We look out for the vertex of the angle, and the vertex is on the center, and two sides of the angle are formed by radii. So as you can see here, this is called central angle. Okay, so center and also two radius form the angle. So then if the vertex of the angle on the circle and also two sides of the angle formed by the two chords, then that is a inscribed angle. Okay, so because the vertex is on the center. So a non-example will be like this. If you look at the vertex of this angle, not on the center, not on the circle, so it is neither. So it is not a central angle, not inscribed angle. Okay, so next is a very important relation between central angle and inscribed angle. Before that, we are going to introduce something about intercept arc. So let's get started. So when we look at the intercept arc, first we look at the two endpoints. As you can see, when we look at the central angle, the two sides of the angle intercept on the arc. Let's say these two endpoints as A, B, and this piece we call intercept arc. So we put a little curve on the top to represent this is arc. Okay? So the reason we mention that because the arc, we can define the measurement of the arc, which is also can define as the measurement, and the unit for this one is degree. So the definition for this piece of the arc, same as central angle. So for example, this central angle is 60 degrees. Then this piece of the arc is also 60 degrees. So as you can see, the whole circle, we all know this 360 degrees, so that's why we can say the whole arc is also 360 degrees. Okay, so that's how do we define the intercept arc. The reason we mention that because the next part is we are going to use this piece of the arc to define inscribed angle. So as you can see, this angle, the two sides of the angle intercept on the arc as, let's say this piece is CD. Okay, so as you can see, this one is called intercept arc for this inscribed angle. Then the definition for this intercept angle, M here, is defined as half of this piece of arc. So, for example, if I know this piece is, let's say, 50 degrees. For example, I know CD, arc CD is 50 degrees. So according to this definition, I know this inscribed arc, inscribed angle, is half of this arc, then it's going to be 25 degrees. Okay, so that's how do we define the inscribed angle based on its intercept arc. Then, so next you will see, based on these two definitions together, we will know inscribed angle and the central angle here. So since these two angles, they intercept the same arc, then that means central angle same as this piece of the arc. Inscribed angle is half of this intercept arc. So that's why these two angles, angle O, central angle, is twice of inscribed angle. Okay, so what does that mean? That means, for example, the central angle is 2 times the measurement of inscribed angle. So let's see, if I know this is 30 degrees, then what do we know about this central angle? It is, yes, 60 degrees, because the relationship is doubled. Okay, so another thing we can see, let's check another example. So the first time you'll say, hey, it looks like these two are the same, but if you look at carefully, you will see this angle, the vertex is on the center, but this one is on the circle. And the way I check this piece of the arc, and then I go back to trace the angle. So if I look at this one, go back to trace, okay, this is a central angle here, and then go back here again, then this is a right angle. So for example, if I know this is, let's say this is 70 degrees, just example, and then since it's central angle, so we'll go back to trace this one, so we know it's gonna be half of this one, which is 35 degrees. Okay, so I use this one to trace central angle and go back to trace here inscribed angle. That's how do I do this one. Again, this is when a central angle and inscribed angle, they have the same intercept arc. This is how the relation look like. This is how it works for this one. Next one is, what if we're looking at inscribed angles with the same intercept arc? What does that mean? Let's check this one. So if I, as I discussed before, I look for the intercept arc here. I see the 2 endpoints here, A, B. So I go back to trace here. So it's linked to this one. And also I go back to trace. So I look at endpoints, go back to trace this one. So it linked to another inscribed angle. Again, the vertex is on the circle, right? Okay, let's label this T. So the fact for these two angles, they are congruent. So when inscribed angles with the same intercept arc, they are congruent. Okay, that's a fact. So that means if this is 35 degrees, then it will be 35 degrees. Okay, so some student might say, hey, what about I'm not looking at the top one, I'm looking at the bottom one. And it's true. So let's check another example. It looked like exactly the same, but this time we're looking at the different arc. So let's check the bottom. So this time I still see 2 endpoints, but this time I'm looking for the bottom one. Okay? So now, again, I use the 2 endpoints to go back to trace angle. 1, B, 1 is A. Okay, so what do we know about that? Angle B is congruent to angle A. So let's say this is 75 degrees, just example. Then we must know this one must be also 75 degrees. Okay, so that's a fact. When the 2 inscribed angle have the same intercept arc. Okay, so sometimes, is that possible we can have more than 2 inscribed angles share the same intercept arc? That's true. See this example. Okay, so let's just check this piece. Definitely you can check the bottom one. I just give example for the top one. So if I look at this piece and then go back to trace, I use one trace to M, 1 piece angle here, and then use this one to trace this one angle here. So another one here. Do we have more? Yes, we do. So trace here. So what do we know about that? We know all 3 angles are congruent. Okay, so for example, if this is, let's say, 25 degrees, then I know this is 25 degrees. Yes, 25 degrees. So we automatically know they are all congruent. So once we know the measurement of one angles, we already know the rest angles when they share the same intercept arc. Okay, so last piece is what I ask you is the very special type of the inscribed angle. So as you can see, this inscribed angle, so again, if you check the 2 endpoint and this vertex is on the on the circle, so it's the inscribed angle. But very special part is, if you check these two endpoints, this is two endpoints of the diameter. So when inscribed angle intercept the semicircle, semicircle half the circle. So what happened to this angle? As we know, the definition of this angle is half of the intercept arc. Okay, so the special part of this intercept arc is it is half circle. So if we know the whole circle is 360 degrees, then the half of circle is what? Is 180 degrees, right? So since this inscribed angle is half of the intercept arc, so that means this piece is half of 180, which means this is a 90 degree angle. So another way to look at this is when an inscribed angle is the opposite side, its opposite side is diameter, and its ultimately is 90 degree angle. So we're actually looking at a right triangle here. Okay, so that's a very special fact of an inscribed angle intercept the semicircle. The other way you can look at it is its opposite side is diameter, so which make a 90 degree angle. That's a very, very special property when an inscribed angle intercept the semicircle. Okay, that's the very basic relationship we discussed in the class, and this is the very quick summary for the whole relations here. Okay, it's finished.